All right, what do we got? We got a H2 with the durable shifter. All right, let me roll this up here, see if I can kill some of this glare. This is I believe, I killed a lot of glare. I believe this is an 08. We're gonna find out right now. It's 2008 Hummer H2. I'm at a transmission shop, good friends of mine, great clients. And they've been through this transmission, I believe, a couple times. Yeah, we got an 08 Hummer H2. They did find a physical obstruction when they tore the trans down, but now they are having some more issues. And they called me out because they want to nip this thing in the bud once and for all, and I do too. I want to help them do that. And we're starting off with an initial scan here. From what I'm being told is that it drives okay at slower speeds. But I believe after it shifts out of second or maybe shifts out of first, it'll hop into limp mode. And then it's no good. So what we need to do here is we need to figure out, do we have some type of external issue, an input issue into this TCM? So we got P0776 in the engine control module, and that's just indicating that the TCM is reporting a fault. And transmission control module P0776, pressure control solenoid 2 stuck off. This is a current DTC. I just want to flip through here and see what else we got in here, even though this stuff isn't related. Lost communication with BCM. Lost communication with ABS. That's very interesting. I don't know why that would. Lost communication with remote actuator. Device power 1 circuit low. That's more than likely due to the fact that we don't have the best battery in this thing. Control. A lot of communication stuff going on here. I wonder why. Look at the topology real quick. So is that all low speed CAN where these faults are taking place? They're all history, first of all, and I'm not overly concerned with this. I just want to make sure. I mean, this could be a clue as to why they're having a control problem. I don't know what's going on yet. I'm just gathering info. Lost communication. That's in the transfer case control module, which is here. All right. Transfer case control module. That is the high speed CAN. Well, let's stick to what we're here for. We're here for this. That's what we're here for. I don't think this is going to work because Alltel's made some changes. So let me get another device up and running. Oh, wait a minute. Electronic pressure control valve. Convert. One thing we know is this. This transmission's been gone through. They did find some stuff going on inside of it. It's all been repaired. This is not the first time that we've had something pop up on this. And I believe these guys with 100% confidence. They know what they're doing. So I'm going to go out on a limb here and say, when they tell me that there is no obstructions as far as flow or anything mechanically going on inside of this transmission, I believe them. So let me get service information up, and let's come up with a test plan and knock this thing out once and for all. All right, so we got our P0776. All right, and what I'm looking at here is the conditions that have to be set to run this DTC, meaning that when it says run DTC, it means be able to check the vehicle for it, if that makes any sense. Not set it, but the things that have to be present in order for this to monitor for this DTC. Couple things that are sticking out to me, obviously, is fluid has to be warmer than 32 degrees, above freezing temperature. Not for transmission, but you know what I mean. TCM high side driver enabled. Average driven wheel speed must be greater than 80 RPM. This is an input, an external, meaning outside of the transmission. This is an input. So this is something that needs to be monitored. Side by side average. It's another 150 RPM. Input shaft speed must be greater than 60 RPM. So I need to monitor this. I need to see to make sure that the solenoid is being commanded on, which I know it's going to be commanded on. I don't need to monitor that. Third or fifth gear ratio has been achieved. Okay. Something that I found here that was a little interesting. No, it's not that. Let me back up. Let me go here. Here. Go here. Let me see. Electronic component description. I'm not worried about that. Go back. I was just fumbling through some diagrams and I saw something that I wanted to point out here that's going to be key. Yeah, right here. So here we have automatic transmission, control solenoid valve body assembly, and then transmission control module. So a lot of people know this, but this is more about showing a process, a diagnostic process that you can go through to troubleshoot, okay? So we have the automatic transmission. This dotted line means that there's more to this diagram. There's more to this than that we're seeing. What we're seeing here is just the information that's critical to what we're looking at. But there's other information that's not being showed on this diagram. That's what this dotted line means. Basically, we're looking at 3 wires here. There's more wires. I think it's 16. Don't quote me on that. But we're only looking at what's critical to this diagram. But what's interesting is that we got valve body, and then internal to the valve body is the transmission control module. Okay, so the reason why that's critical is because at any of these points, I can't do any testing. All right, so I can't see how the transmission control module is controlling this valve body outside of scan data. I can't see any front door data. I can only see back door data. So the way I'm going to go about diagnosing this is I want to make sure that this, where are we at here? This is a non-OE diagram. Here's our transmission. Here's our transmission control module. It's on both sides. And here is the valve bodies. The valve body, here's the solenoids. This is the solenoid in question. Right here. This is the one that's throwing a code. obviously controlled by the TCM. And again, I can't do anything about this. I can't test this. If there is a fault between here and here, this entire unit gets replaced as one piece. So what I need to do is I need to monitor this battery voltage here. Make sure we're not losing this battery voltage. I need to monitor this ground, and I'm going to do all this on the oscilloscope. I'm going to make sure this ground doesn't go high. I'm going to make sure that this power doesn't go low. I'm not overly concerned with this brake switch signal, nor am I concerned with this wake up. I am going to monitor this ignition voltage here, this pink wire. I'm going to monitor these 3 wires, and what I'm going to do is, and the preliminary test is going to be to set that up, because what I want to do is I want to see this fault set, and I want to make sure that this ground doesn't go high or one of these power inputs goes low, which would eliminate a power ground problem. And then the next course of action would be to see if there's some type of communication issue. Here's our bus. It's 4 wires. During my first initial test, what I'm going to do is I'm trying to gather as much information as quickly as possible, right? So I'm going to get the scanner, and what I'm going to do with the scanner is I'm going to monitor vehicle speed. I'm going to look for a PID for wheel speed. A couple other things here on this list. I'll get more. I'll get all the specifics when I'm ready to go. When I'm ready to do this. But the thinking is, I want to make sure that we're not dropping an input to the ECM. All right, this goes to the ECM, and the ECM communicates this over the network to the valve body, or the transmission control module, which is in the valve body. So I want to make sure that the ECM isn't dropping out some type of an input. And what I'm going to do is I'm going to monitor that on the scanner. I want to monitor these inputs on the scanner. And in doing that, let's say I'm driving. I don't lose power or ground, right? And let's say the scanner, something goes crazy on the scanner. Maybe this drops out, or let's say I lose communication altogether with the TCM. What I'm going to do next is I'm going to switch from monitoring powers and grounds, and I'm going to switch over to monitoring network data at the TCM to make sure that we're not losing communication. So if the TCM drops out, no longer is communicating, but my bus is up and still active at the TCM, then that's going to point to an internal problem. Something that's kind of interesting was just flipping through this. We saw some communication related codes. It makes me wonder. But that's going to be the course of action. The first test on the oscilloscope, powers and grounds, and on the scanner, PCM inputs to the TCM, as well as the running condition inputs, so that this code is being monitored. Yeah. This is the kind of stuff you don't want to see when you're doing electrical diagnostics. Let's take a look at this real quick. That's not good. Trying to see where that goes. I don't think that has anything to do with our problem, but that's no good. All right, so we got the PicoScope hooked up. The red channel is what is the red channel? I want to say that's ignition voltage. The blue channel, I got it all written down. I'm just going off the top of my head here, man. The blue channel is ground. That is TCM valve body ground. The green channel, I actually have a current clamp around the the 15 amp transmission voltage input. I want to see, I know that it's good right now, but I just wanted to see for some current spikes. I want to see if this thing drops out, right? I should see a change in current, and that's what I'm looking for. Because now here I'm monitoring the solenoid 2 pressure command. I want to see when that comes on. I have voltage going to, that's internal voltage on the TCM, and I'm monitoring the RPM, the speed of the input and the output shafts. This is just a quick first test. We're gonna see what happens. We have no codes in this thing, so we're gonna drive it. And basically what I'm looking to see is if nothing happens here, and we remain in communication with everything here, this doesn't drop out, and we pop a code and go into limp mode, and all of these inputs here and these inputs here all remain solid during that time, then we could pretty much say without any shadow of a doubt, I mean, obviously I'll do a couple more looks and tests to make sure, but we could say that this is an internal problem at that point. So I'm gonna go ahead and drive this thing, and we'll see what happens. All right, so here I am right now. See if you can see that. The pressure command for solenoid 2 is yes. See, we have our RPM inputs. I mean, this thing's not even doing anything right now, but we are not dropping any power. We have no fluctuations in current. We don't have a rise in our ground, anything. So we popped the code. We actually popped a completely different code. Pressure control solenoid stuck off. This popped, and we had no change in voltage. We had no drop or loss in communication with the scanner. Okay, that's pretty interesting. I'm gonna do one last silly little test. I'm gonna get you all the way in on here. I am going to actuate pressure control solenoid number 2 on. Can you hear that? Heard it click. Now I'm going to do number 5, which is the one that just threw the code just now. Hear it click. So we could bi-directionally control these things. Clicking doesn't mean that it's opening. And that's probably what we got going on here anyway. But just wanted to show that we can bi-directionally control this. And we get an audible sound, although it does sound kind of weak. It's getting dark. So I wanted to do a video to kind of close out the diag on the Hummer. And basically, something's going on over here. Got the police out here. Bear with me. But yeah, basically, the point in the video was we're trying to isolate whether or not the problem is external or internal to the transmission. Oh, look at this. Looks like they need a mobile diagnostician. Anyway, the point was trying to make sure that we don't have something external going on. When I'm saying external, Well, you saw it in the video. You can see it in the diagrams. Powers, grounds, and communication. Now, the way we set up the initial test was just an initial test. It's just that. It's a quick preliminary test that helps set up the next test. And we base that on just some common sense, some knowledge of the circuit, understanding how it works. And yeah, that's basically it. So interesting that the transmission threw yet another different solenoid code. So I went in there to attack pressure solenoid 2, and when I cleared that code out and went to drive it, it threw a code for pressure solenoid 5. There is absolutely 100% no external controls for the solenoids. It is all internal. So what's important is to monitor all of the data inputs that are necessary for the TCM to be able to function correctly. Something that I was a little bit concerned about was some of the vehicle speed inputs. Those were all valid. We weren't dropping out any power. And also, I gotta turn my headlights on. You know, current ramping the main power going from the box from the fuse box to the valve body to see if just to see if there's any blips, any changes in current when the fault code is thrown. And then basically we close it out with making sure that the solenoids can accept commands, which kind of leaves it all the way down to it's an internal problem. It's something between the transmission control module and the solenoid pack, valve body, and they're all one unit. They're all one piece. So that's that. The point again of the video is just to show how we could take a system, and I know a lot of you guys that are more advanced already know this. You probably know the system like the back of your hand, but this is more about showing a process, and you could apply that process to anything. Just look up the description and operation or theory and operation, understand how it works, and start tackling it. So I guess this thing gets a valve body, and that's that.